All right, we are looking at proportions and ratios, so let's dive right in. Our objective here is that we want to be able to solve proportions not only numerically, so just with numbers, but also in a real world setting, so essentially word problems. Then the other thing we're going to do is we're going to take ratios and apply them to determine if a polygon is similar. We're going to look deeper at triangles in a different video, but this is just going to kind of give you a base understanding of it. So, a couple of definitions. First, proportion. A proportion is just an equation that states two ratios are going to be equal to each other. So ratio something over something is going to be equal to something over something. That's going to be a proportion. So two fractions equal to each other. A ratio. Ratio is just a relationship between two similar quantities. Doesn't matter what they are. It's just going to be a relationship between those two quantities. And then a similarity ratio is just the ratio of the length of one side of a polygon to the corresponding, so basically the side that's in the same spot of a similar polygon. So let's take a look at this. Numerical proportion. So what we have here is 11 over 6 is equal to 3 over x. So we're going to go ahead and we're going to solve for this. Now, the way we typically do that is we take the top number and multiply it by a bottom number. So we'd get 11 times x. And same thing here, we'd get 6 times 3. Commonly, what you're going to see people do is cross multiply. And so they're going to kind of make a little circle or a little shape around that to just say, hey, we're going to multiply those two things together. Then we're going to solve for our variable. So in this case here, we're solving for x. So 11 times x is 11x. 6 times 3 is 18. And then when we solve just that one-step equation, we divide by 11 on both sides. We get x comes out to be 1.64. And so that's what we'd end up getting there. All right, this in a real-world setting. Frodo used 8 loaves of lembas bread when he was on a 12-day journey. If he plans a 20-day journey, how many loaves of bread should he pack if he eats the same amount? So that's essentially what this is saying here. So we're going to set our proportion up. So we're going to say 8 loaves is going to be for 12 days. And so he's planning on going on a 20-day journey here, or 20-day adventure. So how many loaves of bread? I'm going to say that my variable is just going to be L. So in this case here, we're just going to cross multiply. 8 times 20 is 160. 12 times L is just going to be 12L. And so we're going to solve. Divide by 12 on both sides here. 12s cancel out. I'd get L comes out to be 13.33 repeating is what that comes out to. So the way that you can answer this, you could say 13.33 repeating loaves. That's one way you could say it. Or the other way you could say it, since we're dealing with a real world application here, it's kind of hard to bring a third of a loaf on something like this, especially a lembas bread. So it might just be easier to bring 14 loaves. So either one of those would be okay. This is probably what you're going to end up seeing if it's going to be a literal thing. If you're wanting to find out in like whole numbers, it's probably going to end up being this here. All right. Now, let's take a look at a ratio. A ratio is just going to identify with the corresponding sides there. So what you're going to see is your corresponding sides are going to match up, and we're going to put it into that ratio of some number over that. So essentially, we're setting up kind of a big proportion here. So what we want to do first is we want to identify our corresponding sides. Well, to do that, 45 down to 105, 45 degrees down to 105 degrees. Those are corresponding sides. So really look at your angles to be able to match it up. And so 45 to 90. So we've got that here. We would have 120 to 90 right here. And then we'd also have 105 to 120 right here. So those are our corresponding sides. Well, the way that we're going to go ahead and set up our ratios are just going to be taking from one to the other. I tend to go left to right. So 11 over 110 is going to be that. Well, that ratio is going to be the same as 15 over 150. That's going to be the same as 4 over 40. All I'm doing there is just taking the left pink over the right pink, the left orange over the right orange, the left yellow, which is 8, over the right yellow, which is 80. And so that's what I have here. So those are all my ratios. Reduce if possible or if necessary. So in this case, 8 divided by 80, I could just reduce that down and my ratio would come out to be 1/10. And that's actually going to be your similarity ratio as well for those polygons. All right, last but not least here, similarity with that. So again, what we've got here is we're going to identify corresponding sides. And so I've got 15 and 10. Those are going to be similar. And so to be able to find these all out, I'm not going to highlight all of them, but I'm going to go 15 over 10. And I'm just going to go left to right, 6 over 4. So 6 over 4, 9 over 6, and then 12 over 8. If I reduce those down, 15 over 10 is 3 halves. 6 over 4 is 3 halves, 3 halves, and 3 halves. All the ratios must match. That's the similarity ratio. So we would say, yes, they're similar.